So, dann fangen wir gleich auch an mit dem Aufbau für den nächsten Vortrag. Ich stelle auch unseren nächsten Referenten mal vor. Okay, let's switch to English again, because the next presentation is in English. And do you understand German?
Nix Deutsch.
Okay, very good. Well, Gerald Youngblood is the founder and CEO of FlexRadio Systems, and FlexRadio is leader in the software-defined radio technology market, particularly for the amateur radio sector. In 2003, FlexRadio introduced the first true SDR transceiver for the amateur radio usage, the SDR 1000, and FlexRadio currently markets a complete family of direct sampling radio servers. Note the wording, radio servers, that's interesting. The Flex 6000 signature series, along with multi-channel receivers for the signal intelligence market. Well, that's for the military. Gerald's career spans over 45 years in the technology industry, where he founded or helped to found 8 companies. Wow, that's good. 8 companies is quite a lot. 8 companies related to computer hardware, software, and peripherals. In 1994, he led Sunriver Corporation, later Boundless Corporation, to become a publicly traded company with a $140 million in 1996 sales. So,
thank you.
Stage is yours.
Glad to be with you. I'd like to give you a little bit. He mentioned the word radio server, which might sound like a different term. So I want to give you a little idea of what a radio server means and how that applies to how radios can be used in a totally different way from the way we've thought of them in the past. And I'm going to talk about application programming interfaces for software-defined radio that makes it easier for many people to program to a radio that might not have considered programming a radio before. There are 3 things I want to talk about. The SmartSDR, which is our software system for the Flex 6000, has an application programming interface, and I'll talk briefly about what that looks like and how you program to it. I'm not going to teach you how to program it. I'm going to give you some examples. I'll also show you an example of where a customer has taken that programming interface and is using it in a very interesting project called the Glass Project. And then I'll also introduce you to another example called Maestro, of where we've implemented the API in a specific type of application. So if you think about, what if my radio were a server, what would that make radio like? If you'll notice over here on the right, this is my K5SDR shack that I took last Wednesday. I have a 12U rack, and I have a Flex 6700, an i7 server in there, and some controls for my antenna relays and so forth, as well as my network interface. This is my radio station right there in that server rack. To that, because it's a server, the radio is a server, I can connect various clients. They could be PCs, they could be tablets, they could be smartphones, they could be portable devices, as I'll show you here in a moment. So what does the SmartSDR API look like? Well, if you look at the bottom, you can have any Flex 6000 series radio. Inside the radio is a very high-performance field programmable gate array, plus an ARM microprocessor running at 1.4 gigahertz and a DSP, TI DSP running at 1.2 gigahertz, plus about 3 other processors and 1 audio DSP. All of that in one radio. And that's running on the Linux operating system, and there's application software written on top of that, and an interface that talks through standard UDP and TCP IP packets to control and send data between the server and a client. In our particular case, we have a client that runs on a Windows computer, and it has an application programming interface called FlexLab. So there's an application, there's a layer that's at the network layer that you can program directly to the network layer, and then on top of that we've built an application programming interface on Windows that allows us to make very simple calls to the radio to do things within the radio. And on top of that is the actual user application running in Windows. So to break this down a little more, you can see on UDP we have a number of different things. We have waterfall data, if you know what a waterfall is, pan adapter data, which is spectrum data, metering, we have IQ data, RF IQ data, as well as discovery packets coming out. So let's see. Yeah, okay, thank you. And here we have, on TCP IP is all of the control data. This says maybe switch and antenna would be an example of control data. So let's talk about the API standards. We could find no standards for control of a radio over a network. They just didn't exist. There are standards for streaming data. So we had to create our own interface between the radio over a network to control it. And so we wanted a very simple interface that was human readable, that could be controlled over, you could open up a telnet, you can telnet into the radio and actually control the radio by typing into a command line. That was how simple we wanted to make it. And we actually have an example of a command line here, and I'll break this down in a few minutes and show you a little more detail. But streaming, we use something called VITA-49, which is a standard for streaming radio data along with the context data over an Ethernet connection or an internet connection. We also provide IQ and real IF over VITA-49 between 24 and 192 kilosamples per second. All of this is available. So connecting to the radio, here's how you connect to the radio. You create a TCP/IP socket at 4992. You receive back a handle. This is the handle. Tells you what version number, and there's your handle. That's how you know how that you've connected to the radio. And then you send commands. That's the way we get started. The interface is asynchronous, and commands are non-blocking. So we can send a stream of commands, and the radio will handle those commands. The format is like this. We give it a sequence number, C134, and we say slice. We call a receiver a slice because we take a wideband spectrum at 245 megasamples, and then we slice it up into receivers. So we call receivers or slices. So we're going to slice create frequency 7.243. That's a command that you can send over a terminal. And the response from the radio will be, this is a command, that's a response, R134, so I know what I got. And this is a code that comes back that can be decoded. If I have an error code, I know that what's the cause of that code. And then we can also ask for status. S means status. And we can say status slice 0 frequency equal, and it will respond with the frequency. Simple as that. The other example is, what's my filter setting for slice 0? Slice receivers, let's create a slice. We're going to do slice create frequency. This is the protocol, frequency, antenna, and mode. So here's an example. We'll create 14.236, and the mode is free DV, which is digital voice. That would be an example. And we left off, in this case, the antenna. We're leaving the antenna the same. And it responds with R34 to say that it's received it. So let's tune a slice receiver. In this case, we say tune slice receiver 0, and we're going to give it a frequency, and that tunes it. You can do this through code, or you can do it through the command line. You have an interactive command line interface with the radio. To change slice receivers, we're going to set the slice frequency equal to a value. In this case, we can set up diversity. If we have two spectral capture units, we can have true diversity. And we can say that this slice is not a transmitter. If we put a 1 there, it's a transmitter. And we can set it in record mode so that we're actually going to record digitally that information. So I've just told you how to program the radio. Using that command structure, you can program this radio. You can do it in any language you choose. You can do Perl script, for example. You can do it in Visual Basic. You can do it C, or whatever you want to do. Ada, whatever those things are. Fortran. So pick your poison. I learned Fortran in college. So let me give you an example of K6TU took this application programming interface on July 1st, 2013. He asked 3 to 4 questions of our developers, and he began delivering a beta iPad application on August 18th. That's 6 weeks. He went from not knowing anything to having a control application on the iPad in that period of time. He developed it he actually created an Objective-C library. He took the Flex Lab and converted it to Objective-C, and that's available. You can get that library if you want to program with it. Let me also point out, you can go to our web page, and there's a launch that you can get our API. There's a wiki for the API. You can start programming with it. It's an open API to program with. So let me give you some examples. So this was on our FlexRadio community. This particular person started on April 25th. He said, I started working on an Android app. On the 26th, he said, now we're getting somewhere. I successfully graphed live FFT data. On the 26th, he said, here's what I have so far. Much better, methinks. 27th, I got a PAN adapter successfully run on Android. At May 8th, here's a little demo. And let's see. Usually it'll play. I didn't play it, so let me see if I can go back. Does this have audio? We don't have audio here, probably.
Yes, you can.
Plug it in.
It's not working. Well, I don't want to take too much time. Let's. Oh, you can play. It didn't play. It should play when. Okay, let's see. Here we go. How am I doing on time? Is it not playing? Oh. How's my time?
8 minutes.
8 minutes. Okay, I'll need to move a little faster. Let me just skip over it. Sorry, I don't lose all my time.
Yeah, okay.
Let me just skip. I can go back.
Go back to
because I have more to do. So, what platforms can you use? OS X, iOS, Linux, BeagleBone, Ubuntu, Arduino, Windows. Those are being developed by various people. We develop on Windows. The radio runs Linux in the box. Windows, we run a small client on it. Let me give you an application. Global AIS. It's like packet radio for ships. We were approached to put a Flex 6700R on the International Space Station for this application. We actually partnered with a system integrator. They've written all the software. We have a waveform API that you can transfer waveforms into the radio, and they're using that waveform API to do effectively track ships on the open ocean. So ISS, starting in December, will have 2 Flex 6700Rs tracking ships across the world. That's an application. I'm going to skip some of these things because I don't have time, but here's what it looks like. These are the racks. These are standardized racks on ISS. And this is an image of a Flex 6700R circuit board that they took out of the radio and packaged it for ruggedization. This plugs into the rack on the International Space Station. And so this is kind of the history of it, but I'll skip over that. So it will go into orbit for a year, and they'll collect data and then decide whether they take it into commercial operation. Let me talk about something that we developed using the API. We were asked to, our customers were saying we want an efficient user interface for contesting and DXing, and we don't want to have a computer to run the radio. And so we created something called Maestro. And we heard that we want very simple interface, knobs and buttons, not hundreds of knobs and buttons, but a few that do exactly what we need. And we want to make it very intuitive and easy to operate. So since I have very little time, I'll just hold it up and show it to you. This is a Maestro. It runs Wi-Fi, Bluetooth, or wired Ethernet. It's battery powered. I have a 10 amp hour smartphone charger that's powering this unit. Weighs 1.8 kilograms with the battery. With this unit, we can walk all around the floor out in the show area and control the radio that's on a live antenna outside with touchscreen control or knob control. We can zoom, pan, so forth. So this device operates any Flex 6000 without a computer, remotely. If you think about that, there's never been anything like that you could Wi-Fi control. I have connections for key, microphone, headphone, speaker output. It has a built-in 2-watt speaker. All of the things that you would need in a radio in a very small device. So I can take it in the living room when my wife is watching TV, and I can chase DX, or I can go on the patio and drink a beer and chase DX in the garden. So it's a very different way. So the power of the server radio is that all of the hard work is in the radio. It only takes, you saw these people were developing clients in very short periods of time. This client software that you see is fully functional. I'm in a demo mode here. Fully functional, and it became fully functional from 0 to fully functional in 3 weeks, 3 calendar weeks. We had one person doing the graphical design who is not a programmer. He did the graphical design, and another person doing the actual coding to link the graphical design into the radio using those same commands that I showed you. So it makes client development very fast because all of the heavy work is done inside the radio. So that's another example of using the API. And Stu K5SDR that I mentioned with the iPad app is doing a full iPad app with pan adapters, spectrum display, or waterfall with virtual private network built in, so that you can go. He said he was operating it from the grocery market. He was operating his radio from his iPad over VPN in a real remote mode, not a remote desktop. I'm not talking about remote desktop, I'm talking about true remote. So that's an example. I'll take some questions at this time. Yes?
Yes, can you also, with this?
With the API, is it also possible to control 2 radios at 2 locations and make a diversity receiver from those, while they're only connected via TCP IP?
It is certainly possible to do that, to control 2 radios from 2 locations. When I bring up our software in our office, I see 20 radios that I can pick from a chooser. So you can access all of those over TCP IP.
Does that mean the Flex 600 can be made phase coherent, or at least frequency coherent? Can the Flex 6000 be fed from an external clock? So it
yes, it can.
Okay.
Right, and the Flex 6700 has 2 phase synchronous receivers in it as well. So inside that radio, it can do true diversity.
So coming from an API programming background myself, to do synchronous receivers, you usually have the problem to tell one or both receivers to exactly start at the same time, tune to the same time, so that the LOs are the same phase and stuff. The telnet-based protocol doesn't really lend itself to that, because we can't say, hey, that's the time we want to do that. How do you solve that?
That has to be done in the field programmable gate array.
Okay.
That code is not currently in the FPGA, but we know how to do it. Right now, it's phase synchronous after you set it. It stays phase synchronous, but it doesn't tune phase synchronous. But it can be done.
Thanks.
In Power SDR, there was a possibility to make diversity using two antennas and phasing and changing the amplitude. How about signature series? Will it be soon available?
I didn't hit the question.
I think it was called in changed signal clarity or something in Power SDR. You can make diversity reception with two antennas.
Yes.
How far away it's with Flex 6000 series?
So how far away is it diversity? You can do diversity today, simple diversity, using your ears today on the 6700. We're working toward what we call optimal signal combining, where the radio votes on the best signal-to-noise ratio. We probably will start development on that in the not-too-distant future. I can't give you a date. But there are people, in fact, one of them in this room over here, working on that. So,
for me, it's important. That's why I asked.
yes.
A question on SmartSDR API. You said it was open. Would you oppose other SDR manufacturers if they adopted that protocol?
They certainly could, because it's published, but they would have to do all the work behind it, which is many man-years of work behind that code. But they certainly could do that. They absolutely could.
I have a question. Could you remote control transmitters?
What was the question?
That's me.
Okay.
Could you remote control transmitters, and what latency is expected, especially, for example, for CV operation?
Okay, so can you remote control transmitters? And the answer is yes. Today over VPN, and within the future we'll do it natively in the radio. The internet has an inherent latency that we can't change. That's physics. So it will be dependent on your upload, download speeds, and the latency of the internet. Within your local network, it's completely transparent. With VPNs, you almost can't tell the difference if you have good speed. I have 50 megabits down and 5 megabits up for $69 a month. And I could actually negotiate for better, but we have 100 up and down at work. So.
The RTSP is implemented, so it's going to work on, RTSP is implemented, so it's going to work on the WAN eventually, but there are limitations, of course, by the variance, the time variance, and all these things, so the protocol has to adapt to these changing latencies. So it's possible, there's going to work, we have to be done to do it.
Yeah. Do we still have time?
Is there also some things like a password on it, so that no people can do a QSO with you without being available?
It is also possible that could occur. You could completely automate a QSO. We've talked about that, especially digital modes. Yeah.
Do you have security features enabled if the TCP connections get terminated and the transceiver is on TX mode?
In the current software, we prevent operating over the WAN currently unless you use a VPN. We will add security capabilities in the upcoming months that deal with that very issue. We have to add security, discovery. There are 2 or 3 other things that we have to add to give you verification has to be added to it. Those are the kinds of things that we'll be adding over the upcoming months.
Any more questions?
Oh, 5 minutes. I did well.
A question?
Thank you. Thank you.